All right, so moving forward, lesson 7 piggybacks on lesson 6. So it's using how we find a unit rate and applying it to some scenarios or story problems or questions and being able to figure out what is being asked. So we're basically going to be missing a piece of information, and how are we going to find that information? By using the idea of a unit rate. So let's look at the first one we're talking about as the example that's given to us. The Chapt family is traveling from Arizona to Texas. On the first part of the trip, they drove 500 miles in 10 hours. If they continue driving at the same rate, how many hours will it take them to drive 750 miles? So I'm given my first rate. I'm given part of my second rate. I need to figure out what the missing part is. So the way that looks is I take my original rate, which is my 500 miles for 10 hours. Then I'm going to get somewhere, somehow, 750 miles. How many hours will that take? So going from point A to point B, there's work to be done in the middle, and that's where that extra point comes from on your homework assignment. So I know I'm going to have to find my unit rate first, and then apply that information to get my final rate or my missing piece. I know I'm going to divide by 10 because I need a denominator of 1 every time I'm using my unit rate. So if I divide by 10 here, then I have to divide by 10 up above. When I do that, that does give me 10 divided by 10, which is the denominator of 1. Then it gives me 50 divided by 10, or 500, excuse me, divided by 10, which is 50. So I know my unit rate that the family is traveling is 50 miles per hour. But now I need to get to 750. So I have to figure out what 50 cents, if I put groups of quarters in 50 cents, how many times will it take it to get into 750? Or take your handy dandy calculator, take 750 divided by 50 equals, and find out what I have to multiply to go from 50 to 750. Either way works. I'd be multiplying by 15. So I know that 50 times 15 is 750. So still going back to that missing piece, how many hours is that going to take? Well, now I just have 1 times 15, so I know it's 15 hours. Now my answer is not 750 miles for 15 hours. My answer is just the piece that's missing. That's 15 hours. That's going to be my final answer. All right, so it's just reading it, understanding what it's asking, and then using the information that they provide you to find the right answer. My second example they give me is Kenyon earns $105 for mowing 3 lawns. How much would Kenyon earn for mowing 10 lawns? It says draw a bar model. Now you can draw a bar model. I'll explain it here real quick, but I'm not going to expect you to draw bar models if you don't want to. What you would have to do is say, well, I know that for 3, I earn 105, and then we're going to be mowing 10. So I need to figure out what each of these is worth by taking 105 divided by 3, and then I would write it into each of these boxes. That would prove that that amount is how much I get paid per lawn. I would then have to write that same amount 10 different times to see how much he would earn over 10 different lawns. Mathematically, I honestly think it's easier to do. How much would he earn in mowing 10 lawns? Than if I just go through the math steps, they have it set up for me right below. Then I would say, well, I'm starting with 105 lawns, and I know, or $105, and I know I'm mowing 3 lawns. So I'm going to take that information and I'm going to find my unit rate first. So I'm going to divide my denominator by 3, and therefore I'm going to divide my numerator by 3. And then my handy dandy calculator tells me 105 divided by 3 equals that's $35 per yard or per lawn that he mows. All right. So then I have to apply that information to, well, I'm going to mow 10 yards or 10 lawns. So if I multiply them by 10s in the numerator and denominator, then I would find out that I have 10 times 35, which gives me $350. They want to know how much he's going to earn if he mows 10 lawns or 10 yards, then I would have $350. That's the answer that they're looking for. Well, in this scenario, they said, well, what if Kenyon earned $210 for mowing 7 lawns? How much did he earn for mowing 5 lawns last summer? So we're changing our amounts, we're changing our dollar amounts, and we're changing our lawns. I don't know if it's the same amount or not. So let's find out by doing our unit rates. You can draw the bar model, but I don't expect you to draw the bar model. It's just extra work that you don't have to do. If I know that I got $210 for 7 lawns, I set it up as my original rate. Then I have to reduce to get my unit rate, which tells me I have a denominator of 1. So here I'm going to reduce by 7 because that's my current denominator. If I divide by 7 in my denominator, then I have to divide by 7 in my numerator. That's going to give me $30 for 1 lawn. If he got $30 for 1 lawn instead of the 35, then how much would he get for 5 lawns? So I'm missing my dollar amount. Well, to get there, I know I have to multiply them both by 5s because my denominator now has to become 5 lawns for my new rate. I get 5 lawns, and 30 times 5 is $150. So how much would he earn? He would earn $150 because that's the piece that's missing. That's the piece they're asking for. So follow along as we look at the examples of your homework so that when you go to do your homework tonight, you can look back at it and say, oh yeah, I remember those steps. I can do that. Not difficult. I'm also going to introduce to you a different process to do it than the book does. I personally find the process to be easier and quicker, but I'm not going to require you to do it. So following along then. So we have a bunch of blue little boxes that we're missing, and it kind of gets distracted on what we're actually looking for. So what we're looking for is this gray box. What does the gray box equal by the time I get to the final answer? Okay. So when I look at that, then I know that I have these equivalent ratios that we're finding. So I'm going to go at the beginning by finding my unit rate. And why is that? Well, if I know I have equivalent ratios, then before we've said, oh, I can then multiply this number and get that number. I can't multiply 6 by something to get 10, not equally and easily. So therefore, I'm going to reduce. And when I reduce, then I'm going to get my unit rate. That's why I'm going to find my unit rate first. So I know I'm going to change this into a unit rate. They show me I'm going to take and divide by 3. If I divide my denominator by 3, then I have to divide my numerator by 3. That's going to give me a unit rate of 2 to 1. Once I have my unit rate of 2 to 1, then I can ask, well, what am I doing to the 2 to get the 10? Well, that's pretty easy. That's multiplication. That was 2nd and 3rd grade. So I can multiply 2 by 10, or 2 by 5, excuse me, to get the 10. And if I multiply the numerator by 5, then I have to multiply the denominator by 5. And that denominator is our gray box that we're trying to solve for. So if I take 5 times 1, then I know my gray box is equal to 5, and therefore, that's my final answer. Now, just like before, if you want to put 10 over 5 as your final answer, I am not going to count that wrong, okay? But make sure that if it's a gray box, like on a standardized test for NWEA, then you only choose the answer that's there. Either way is acceptable, in my opinion, because you're still giving me the answer. If the numerator was 10, then you know the denominator is 5. So you and I, we're good to go. On question 2, then, they start us out, well, I have 6 eighths, and I need it to equal to 20, and I can't multiply 8 by 20 or by something to get 20, so I'm going to make my unit rate, figure out what to do. Now, they kind of do this in a different approach than I originally would have. We'll look at what my original approach would be here in just a moment. So here they're saying, find your unit rate. All right, so I would have to divide by 8. And when I divide 8 by 8, I get 1. But when I divide 6 by 8, I get a decimal. Well, that's okay. Put your decimal in there. That's what they're saying. It's all right because it'll get you to the final answer. So if I have 0.75 or 75 hundredths over 1, and I need a denominator of 20, then I know I can go from 1 to 20 by multiplying by 20. So if I multiply my denominator by 20, then they tell you, well, you would be multiplying your numerator by 20 as well. Then I pick up my handy dandy calculator, take 20 times 0.75, excuse me, That's going to give me an answer of 15. So if I have 15 20ths, I know my gray box that's missing is going to be an answer of 15. Once again, if you want to put 15 20ths as your final answer, it's acceptable because that's telling me that you know when my denominator is 20, that my numerator would be 15. Now, I looked at this completely different, and I would find a different way to solve it just by looking at how it's setting up. So I'm going to type the way I would have done it just over what they've given you. So maybe you'll see a different way to do it. I looked at it as 6/8, and if I reduce that, I get a decimal in my numerator, which I really don't like to do. So what if I just reduced it not down to a 1, but I reduced it down to a 2? Going back to that previous lesson on equivalent fractions. Could I do that? I absolutely could. So that's what I would do. I would say, well, I'm going to reduce this by 2s, which is actually going to give me a fraction of 3/4. And I know 4 does go into 20 evenly, so that makes it easier for me. I would multiply 4 by 5, which means I would multiply my numerator by 5. So then I have 3 times 5, which is 15, and my answer is still a numerator of 15. Still 15 20ths if you wrote the whole entire fraction. So more than one way to do a math problem. When they give you the guiding steps like they do at the beginning of this one, then those are really the steps that they're asking you to follow. But those weren't there. If you didn't know you had to use the decimal in the numerator, then this would be quite acceptable because it's still getting to the right answer. All right, so we're going to ignore these two problems for just a moment because I'm going to introduce you to something new, but still following the same pattern that we have been doing. Two-step math problems. We're going to divide to get our unit rate and then multiply to come up with the rate that they tell us to have. So I have 40 over 8 is equal to 45 over something, and I don't know what the something is. So I'm going to take my fraction that I have, and I'm going to reduce it to get my unit rate. Well, I'm always going to reduce by what my denominator is. So I'm going to reduce by 8 and reduce by 8. Remember, if I divide by the denominator by something, I have to divide the numerator by something. If I multiply, then I have to multiply. It has to be the same pattern to make them equivalent. I know that 8 goes into 8 one time, and 8 goes into 45 times. Now what I'm doing is going from the 5 to the 45, which does work evenly. I multiply it by 9, so I have to multiply my denominator by 9, and 9 times 1 gives me 9. So my gray box, my missing number, is simply a 9. On question 4, it's the same idea. I'm not going to be able to easily go from 14 to 5, so I'm going to make my unit rate by reducing by the denominator of 14, and then I'll go from there and multiply to get the 5. So I'm going to reduce first. 14 does go into 14 one time, and 14 goes into 42 3 times. And if you don't know that 14 goes into 42, handy dandy calculator, 42 divided by 14 equals 3. Then I can see I can change my 1 into a 5 evenly and easily by multiplying by 5s. So if I multiply 5 by 1, I get 5, and 5 times 3 is 15. So my missing gray box should actually be a 15. On question 7, same idea. I have a 4 over 32 is equal to 9 over something. I can't easily multiply a 4 by something to get 9, so I'm going to reduce first to find my reduced fraction. Now the difference on this one is it's not actually unit rate. This takes us back to an equivalent ratio question. My 1 ends up on top. So I'm going to reduce by the 4, and 4 goes into 4 one time, and 4 goes into 32 8 times. I need a numerator of 9, just simply multiply the 1 by 9, which means I have to multiply my denominator by 9, and 9 times 8 is indeed 72. So my missing gray box is equal to 72. And then number 8 takes me back to being able to find a unit rate with a denominator of 1, because I can't multiply 3 by something easily to get a 4, so I'm going to reduce by 3s. 3 does go into 3 one time, and therefore 3 goes into 9 3 times. And then easy multiplication, I would multiply 1 by 1 to get 4. That would be 4s. So multiply at the bottom and top by 4. 4 times 3 is 12. Therefore, my missing number is a 12. Now, as I said, I left those last two to do something new. So this is a new idea that if you were in Math Bowl last year or the year before, then I taught you how to do this. And if you weren't, you haven't been taught yet. I call this dividing the loop. Okay? Now, there isn't a loop there because I haven't put it there yet. But there's a couple things I have to look at to be able to set it up correctly. The first thing I look for is I look for the loop that's given. And what that means is, what diagonal set am I provided with? Well, in this case, actually both of these, it goes from the bottom left to the top right. So in this case, I have the 2 and the 56, which I could loop together. I'm always going to multiply the two that I can loop together. If you look, I have nothing at 8. I can't loop those. There's nothing joined with it. Has to be the two that are lined up diagonally. So when I multiply 56 and 2, that gives me 112. Then what I would do is I would simply divide by whatever's left. Whatever's left in this case is an 8. So I would take my 112 and I divide by the remaining number that's there out of the 3. So 112 divided by the 8 then, 8 goes into 112. If I take my calculator, it tells me 14 times. So my missing box has to be equal to 14. It's just a different way of doing it. Instead of reducing my fraction or getting down to my unit rate and then multiplying, I just take the two that are there, I loop them, multiply, and then I divide by what's left. Looking at number 9, going through the exact same thing. My first thing is I have to find the loop, the two that are there diagonally. Nothing in 7, I can't loop that. But the 14 and 9, I can. So I loop those, and those tell me to multiply. So 14 times 9 is going to give me 126. My second step, after multiplying the loop, then I divide by what's left. I have a 7 that's left over, so I'm going to take 126 divided by 7, and that gives me 18. So my missing number at the top has to be an 18. Some of you will find this a lot easier. Some of you, you're watching me, but you're really confused. It's not required that you do this. We're not into this lesson, okay? But this works for a lot of different things that we're going to be getting into as we move forward. So I want you to know that's a tool that you can put in your pocket. You can write this down on a piece of notebook paper and add it to your math folder so you know how to do it. And there's 2 examples that you can include on that note in your folder. And then you can pull it back out and look at it. All right, so what I would like you to do is I would like you to do 6 and 10 on your own, find 2 answers. Okay? So I'm going to do it the original way the book introduces, and then I'm going to do dividing the loop. You can do it dividing the loop on both of them or the book way on both of them. Finding the right answer is the key to it. So pause it, find your work, and then come back. So on number 6, hopefully you got to the right answer. First thing that you did would be to reduce your 26/13, reduce by 2. I don't know why I have a 2, it should be a 13. This should be a 13, so 13 goes into 13 one time, and 13 goes into 26 2 times. Then you multiplied by 4 because you had to go from 1 to 4. And if you multiplied your numerator by 4, then 4 times 2 gave you an 8. So hopefully you got an 8 in your final answer. On 10, if you multiply the loop, now some of you may have froze a little bit because you saw a decimal. Don't let the decimal confuse you. It's still the same process every single time. But if I did the loop part, then I multiplied 3 and 1 and 25/100ths. And when I multiplied them, I got 3 and 75/100ths. Then I would have divided by whatever was left. So 3 and 75/100ths divided by 2 is 1.875, 1 and 875 thousandths. Now, if I would have tried to come up with a denominator there, I would have had to divide by 1.25 to get my 1, and divide by 1.25, and then multiplied it by 3, and guess what you got? You still got 1 and 875 thousandths. So if you didn't get to the right answers, and you don't see why you didn't get to the right answers, come and ask me. As you're doing your homework then, you have page 253, 2 through 8, and then on the back page, the review is 254, questions 1 through 6. You may ask for help from one of your classmates or come to me, and I'm happy to help.